So we will be looking at some examples of areas and volumes in this. Let's take a look. So here we have two identical circles intersect, so that their centers and the points at which they intersect form a square of side 1. Okay, so let's draw that. So the circles intersect, so this is one circle, another identical circle, so the centers and the points form a square. So okay, let's say this is the other circle. That doesn't look like good enough, but let us try and draw it once more. Yeah, now it's better. Okay, so the centers and the points where they intersect form a square. So we have a square here. So this is R, R, R and R, all of them are identical circles. So the area of the portion common, so that means we are looking at this area. How do we find that? So what we do is, we find out this sector area. Okay, so what is that sector area? Pi times R squared upon 4, because 360 by 90 over 360 is 1/4. And then we add this sector area again. So we add that again, plus pi R squared by 4. But then this area A that we want is included 2 times, so we remove it once. That will give us the area of the square, which is R squared. Basically we are doing a set theory. Okay, sum of these two minus the overlap is the total. So they are given that the side of the square is 1, means R is 1. So what we have is A equal to pi by 4 plus pi by 4, so that's pi by 2 minus 1. So that is our answer. Let's go to the next one. The base of a regular pyramid is a square and each of the other sides is an equilateral triangle. So we have a pyramid whose base is a square like this, and this is supposed to be the center of the square that we have. Length of each side is 20, so these are all 20 everywhere, all the lines, edges, everything are 20. We have to find the vertical height. So first we will do simply this. Let's call that L like last time. This becomes 10, 10. Now this L is basically the height of that equilateral slanted triangle. So what is the height of an equilateral triangle? Root 3 by 2 times 20. So that's 10 root 3. This is basically the midpoint of the square. So this length will be 10, that side will be 10. Okay. We need the height. So from Pythagoras theorem we have L squared equals h squared plus 10 squared. So h squared is L squared, which is 100 times 3, 300 minus 100, so that's 200. So the height will be 10 root 2. So that is the fourth option. Let's take a look at the next one. It says an insect wants to go from one vertex of a cuboid. So you have 3 by 4 by 12. Okay. So it's kind of a long cuboid. This is 3, that's 4, that's 12. It wants to go from one vertex to the other vertex furthest away. That means this point to all the way here. The shortest distance traveled by the insects when it flies and when it crawls. The ratio you have to figure out. So when it flies, we have to assume that the inside is hollow, so it can just fly through it. So if you look at the line that we want is this, when it flies through. So the base is going to be 5 because the base diagonal, Pythagoras theorem, 3 squared plus 4 squared is 25, the square root is 5. And now we have another right angle triangle. 5 squared plus 12 square is 13 square. So when it flies is 13. That much we know. Now to when it crawls. So crawling, it can go like straight, then straight, then straight. That could be the longest it can take, okay. But then what will be the shorter one? So if I, let's say, draw another such cuboid, the shorter one will be when it is going like this, and from here moves like this, so that when this face is flapped open as if it's a page of a book, then this forms a straight line, and that will be the shortest distance. A straight line is always the shortest distance. So if I want to draw this once more, so what we are doing is, it is going from here. This page that we have now has been opened up like this, flipped open. So it is now trying to go straight like this. When flipped closed, this would have looked like this, okay. So how do you find that? So this is 12, this is 3, and that's 4. So when it flips open, this also becomes 3, right? So here we have a triangle where this is 4, that's a right angle. This entire thing is 15. So this one now becomes, one possibility of this L1 will be root over. So what did we do? 4 squared plus 12 plus 3 squared, and that we have as root over of 15 squared plus 4 squared. So 15 is 225 plus 4 square is 16. So that is root over of 241. So that could be one possibility, that is L1. Okay. Just like L1, we can do L2. So L2 would be, we club 12 and 3, so this time we can club 12 and 4, and that would be 16 square, 256 plus 9, so that is 265. That actually becomes even longer. L2, not L square, sorry, L2. And the last one, L3, we will club 4. So that is 7 square plus 12 square, 144 plus 7 square is 49. So that would be 193. So root over of 193. That's clearly the shortest of them. So to the crawls, the shortest length will be root of 193. That is approximately root of 196, which is 14. Just less than 14. So will be 13.9 or 13.8 around. And we have to just take the ratio of those two. So this will be the answer to this question. So remember, it is like flipping open the pages of a book. I did not show the other one. So like L2, or let's say if I want to show you L3, how we get, we are going to flip this page open like this. I draw it in red so that it's clearer. So it has flipped open. This was 3. Now this has become 3. So this insect is trying to go from here to here. So 4 plus 3, this is now 7, and this is still 12. So this will be square root of 7 square plus 12 square. This is what we have done. Similarly, the third one will also come. I hope this was now clear. Thanks for watching.